Hello everyone and welcome once again. So today we are going to talk about integrating odd and even powers of trigonometric functions. Uh, we know we know we know the trigonometric functions are: we have the sine x, we have the cos x, and we have the tan x, which is sine x over cos x. We have the sec x, we have cosec x, and we have the cot x. We know all these trigonometric functions and what they mean. Like for example, tan x, we know it is sine divided by cos. Sec 1 over cos, cosec 1 over sine, then cot x is 1 over tan. So those are the trigonometric functions that we are going to talk about at this level, but we are going to see how we integrate odd or even powers. So for example, if we have sine x power n, this n can be odd or can be even, like that. For example, if I have sine x power, say 5, this 5 is an odd number. We can write this sine x power 5 as sine 5x, like this. So when we write sine 5x, we say it is an odd power of sine x because 5 is an odd number. If it is say cos x power 4, this is cos 4x, so it is an even power. So that's specifically we are going to talk about, but specifically it will be integrating. How do we integrate these trigonometric functions when we are given a trigonometric function with an odd power? We have a simple technique that we follow when we have an odd power and when we have an even power. So let us go through that. Specifically, let us go through that and we see how we deal with these functions. And I'm going to start with odd powers. So when we are dealing with odd powers, we shall need three things. We shall need the Pythagoras theorem. So we shall need what do I mean by Pythagoras theorem? We shall need that, and we know that 1 plus tan squared x is equal to 1. And then we also know that 1 plus cot squared x is equal to. So these will be our helpers when we are dealing with odd powers. We shall see why do we need this step by step. So you need to be, as a mathematician, you need to be conversant with these three equations. Cos squared plus sine squared is equal to 1. All of them, all the three, because we always need them. So for example, here, when we have odd powers of a trigonometric function, we first split that trigonometric function with its power into a product of two functions, one with an even power and another one with an odd power. I repeat, we first split the trigonometric function given to us into a product of two trigonometric functions, one with an even power and another one with an odd power. And the one with an odd power must have power 1. Must have power 1. What do I mean? Say if I have sine power 5x, before I do anything to this, I'll express it into a product of two trigonometric functions which are the same, but one has to have power 1 and another one even power. So this will be power 4. Like that. That is the first step you have to take. And we shall see why do we need this step for us to be successful. And then after that, we deal with this one with an even power. What do we do with this one with an even power? We just go back to our identities. Since I'm dealing with a sine power 4, so I can express this one in terms of this. How? I know that sine power 4x is the same as sine squared x, then everything squared. This is true. So it means that you see that the one with an even power it is easy for us to express this one with an even power in terms of this, which is very hard to express this one in terms of, say, sine squared x power n. What n can give us a 5/2? And it is very hard for that n to expand this one when we just feed in this one here. So it means that we have to split this one into a product of 2. This is power 1 to power an even number. We know that when we multiply this and this, we still get back this. Hope that one is clear. So you see that we shall have something like this, where we shall replace this with this equation. We know that this is 1 minus cos squared x squared. So when we do an example, you shall see why we always need to do this. And it is all concerned with substitution, which is very okay. For example, let us do an example. Let's say integrate sine cubed x. So if we have that sine cubed x, we have said our first step is splitting this sine cubed x into two sine functions, one with an even power and another one with power 1, the x. Then we convert this one into this. We just look back here. We shall not use this because here sorry. This is sec squared x. I'm sorry for that. I didn't see it. So, but I hope you knew it. So now here, we can't use this because we have to express the sine squared. So we have to use the identity that contains the sine squared. We know that sine squared is equal to sine squared, which is 1 minus cos squared x, then the x. Then from here, you simply expand your brackets. After expanding your brackets, you shall have something like sine x minus sine x cos squared x the x, like that. Mathematically, this is the same as sine x minus with respect to x minus the integral of sine x cos squared x dx. And this is easy to integrate. We know it, that when we integrate sine x, we get negative cos. So this one is done. So the point of emphasis is on this integral. So when we see such an integral, we use the substitution. Substitution how? Say u, we say let u equal to cos x. Because I know when I differentiate my u, I'll get sine x. So it means that du is equal to sine x, but with a negative, we know that, then dx. So where I have dx, I will just replace it. You will see that my dx is equal to du, actually negative du over sine x, such that when I replace this dx here, this sine x that is down is going to cancel with this sine x, such that I have a very simple integral to deal with. So my whole integral is, maybe we can first talk about this one alone. So when you're calculating this, you just put it aside, say for this integral, but for purposes of time, I'm not going to go through all that. So this integral, I can call it integral I. My integral I is equal to the integral of sine x. Remember, I said let u to be sine cos x. So it is sine x times u squared times dx, which is minus du over sine x. This goes with this. So I have integral of minus u squared du, which is minus u power 3 over 3 plus c, which is minus, remember, we have to respect x, though we introduced in another variable u, so we have to go back to our origin. So this is minus cos power 3 x plus, so this is out of 3. This is out of 3. So it means that when we integrate this, we get this one. So I just go and replace and say my integral. So from here, I strictly come here. Hope you're following. So the integral, if we integrate sine, we get minus cos x. Then minus the integral of this, we have got it as minus. That's why it is plus 1 over 3 cos power 3x, then plus c, the constant of integration. As simple as that. So the thing here is to know the steps that you're supposed to follow, which will make your work easier. So I've said that when you have an odd power, first express it in terms or in form of a product of two. If it is sine, make it a product of two sine functions, one with an even power and another one with an odd power, and that odd power must be 1, such that it will create something like this, which you will need to do, or to handle that integral, somewhere you will need a substitution technique, which will give you a derivative such that one of the trigonometric functions, they are just cancelling or moving away. So maybe I can also do another example and we see. And after this example, you can also do several examples and see. So for example, I can give another example. For example, let's say if we have example 2, but if we have an integral of cos power 3x then sine squared x dx, that, so I'm still under odd powers. We have this is a trigonometric function cos x. It has an odd power. The sine x has an even power. Whenever you're given such an integral, first deal with, I repeat, first deal with the one with an odd power. How? Split it. We split this one with an odd power. This can be written as cos x times cos squared x. Then we have our sine squared x dx. Then deal with this one, substitute it with this one. This one will be the integral of cos x into 1 minus sine x, sine squared x, then times sine squared x dx. Then from there, expand brackets and split the integral. So here we shall have the integral. This one is multiplied here, so we have the integral of cos x sine squared x dx. Then minus this times this, then times the other one. So we have times minus the integral of cos x, then sine power 4x dx. I hope you see that this one is multiplied here and this one. We are just opening brackets and expanding. So this is very easy to deal with, and this one is very easy to deal with by letting you to be the sine x, because we know that du will be cos x dx such that our dx is equal to du over cos x. You see that when we replace where we have the x with this one will cancel out, so that we have the integral of cos x, this is u squared, times dx, it is du over cos x, then minus the integral of cos x, then u power 4. This is because we let our u to be sine x, so sine power 4x is u power 4 times du over cos x. So I have the integral of u squared du, it is u power 3 over 3, then minus u power 5 over 5 plus c. So my u is a sine, so I have sine power 3x, a third minus a fifth, sine power 5x plus c. So once you split the one with an odd power, this one will always come naturally. This one will always come naturally in your integral. It will always come naturally. So that's all we can talk about. Maybe I can give, you know the problem with me. I explain a lot. That is my problem. I've realized in myself. I explain a lot. So now I'm going to give you some few examples here. You can try them out.